Hello, it's Terry Dennery of the MathWorks. Um, so in this video, we're going to kind of proceed with our efforts on the DC motor, and we're going to introduce some organization. And the way of kind of creating organization certainly is a big part of why Simulink's a really good tool. And it takes the form of what we call subsystems. And I'd say in my opinion, kind of the most effective way to develop subsystems is to ultimately match kind of the way it works in real hardware. And that subsystems in general, I see as a great vehicle for kind of matching kind of the component subsystem system kind of paradigm that exists in how hardware really gets created. So anyways, I think you'll know what I mean as I move through this. So here's where we kind of left off. In the last video, we created a DC motor, which shows, kind of the things that we're going to want to know is, mostly how's it going to move. Ultimately, there's things like how much power is consumed electrically, what torques and angular speeds and stuff like that are important too. Okay, so anyways, let's kind of focus on this part down here, and we talked about it in the last video, but this is basically my mechanics, that it receives this part of the calculation receives the torque and it'll tell you how fast the shaft is turning. And so we just right mouse click and create the subsystem. All right, and simple enough. All right, and now I just want to kind of again do a little bit more organization. I'll begin by flipping this block. So it's just a natural input. Okay, and again, my familiarity with this is that I know what that is. And it's torque, and it's going to be expressed in Newton meters. All right, and that this is velocity. Now I'm going to correct myself a little bit right now. All right, and that V isn't exactly the best term for angular velocity. In general, they use kind of that whatever Latin or whatever the alphabet is, but we generally call it W because it's too hard to do a omega. Okay, and so this will be in radians per second. All right, and well, that looks pretty good. All right, and so I'll call that my mechanical shaft. And basically everything else is electrical outside of the inputs and outputs. And so I'm going to take everything else like that. And that will be my DC motor. Okay. Let's go in here and kind of see what we got. All right, so I'm going to do, again, a couple things. Let's change the orientation of these things, and then we'll kind of label them properly. And ultimately, I want things going out to be kind of going in the direction from left to right. Okay, and that is current times K, and so that's my torque. I'm going to put the little E in there, and then again, I'll introduce units of Newton meters. All right, and with torque and current kind of being the same thing, they're just kind of scaled by K. I'm going to just delete that to just kind of simplify what this model is about. And let's flip that. Flip the whole thing, Control I. And let's move it all over here. And this, of course, is velocity coming in, which will be the basis of my back EMF voltage. And again, I kind of like putting units in, so let's make that radians per second. And then, of course, this is my applied voltage, and voltage is almost always expressed in V for volts, and so I'm going to just kind of leave that like that. All right, and with that, we're getting pretty close. We're not measuring current anymore, so let's move that like that. Let's stretch this. And it's always good to give something a name. And I think the best name I could call this is the DC motor. All right. Hit enter, and there you go. Some nice organization.